The goal for this exercise is to rationalize the denominator, to get the roots out of the denominator. But what's particular about this exercise is that instead of having a square root on the denominator, I have a root of grade 4. This is the expression that we're going to try to rationalize to get the root out of the denominator. We have x multiplied by y cubed, also multiplied by the fourth root of x, and all of that divided by the fourth root of 125x. So, to get the root out of the denominator, I do something very similar to what I did to get the root out of an expression with a square root on the denominator. I multiply by a new fraction, which has the same thing on the numerator and the denominator, so this is like multiplying by 1. Okay? Now, I have the same root as the denominator on the new fraction. And I have the same radicand on the new fraction. What I have different now is that instead of having an exponent equal to 1, which is what I have here, I have an exponent equal to 3. And what happens with that exponent that equals 3 is that now when I perform the multiplication of the two denominators, I'm going to end up with a fourth root and a radicand with an exponent equal to 4. And I'm going to have the same exponent as the grade of the root, so I can get the radicand outside of the radical sign and basically eliminate the roots from the denominator. Let's do that. Here we go. We're going to multiply these two expressions, okay? One is the fourth root of 125x, and the other is the fourth root of 125x, but this 125x is in parentheses with an exponent 3. When I have that, I'm multiplying two roots of the same grade with the same radicand, 125x, but one radicand has one exponent and the other radicand has a different exponent. The result of that multiplication is going to be a root with the same grade as the other roots that I had before, going to have the same radicand, and the new exponent is going to be the addition of both exponents. The addition of this exponent, which is 1, and the addition of this exponent, which is 3. Now, these two terms right here, when multiplied, become the fourth root of 125x raised to the fourth power. Okay? And on the numerator, I have what I had from the original expression and what I had from the new fraction that I was multiplying. Okay, this is the first numerator, and this is the second numerator that I added from here, from the second expression that I was multiplying. So now what happens? Since I have the same grade as the exponent in the radicand, just like with the x here, if I have the same grade and the same exponent, I can get rid of the exponent and the radical sign, and that just equals x. So in this case, I can get rid of the radical sign, I can get rid of the exponent, and what I'm end up with is just the 125. So that's what I have here. 125 on the denominator without exponents and without any roots or radicals. So I am done with the part of removing the roots from the denominator. What I'm going to do now is try to simplify what's left in here. First thing that I'm going to do is that I'm going to apply the exponent 3 to the 125 and the x separately. I can rewrite this as 125 cubed multiplied by x cubed. Now that I do that, the next thing that I do is that I multiply this root right here with this root right here. If you see, they are both fourth roots. So what I can do is put all of that into one big radical sign with grade 4, and now I multiply this x cubed, which is here, with another x that comes from this x right here. Okay, so I now have on the inside of the radical sign x cubed multiplied by x, and x cubed multiplied by x is x with an exponent 3 multiplied with x with an exponent 1 equals x with an exponent 4. I keep the same base number, or in this case base variable, the x, and I add the exponents. This is 3. This is not written here, but you should know that that is an exponent 1. So it becomes x to the 4th power. Now I have x to the 4th power inside of a root of grade 4. So you know where I'm going with that, right? I can take this x outside of the radical sign. That's what we used to say most of the time. Just take the x outside of the radical sign because it has the same exponent as the grade of the root. That's okay, but that's not exactly what happens. We are actually skipping a few steps. If you have practice, you can just take it out. But what really happens is that I separate the roots. Okay, I separate it into the fourth root of 125 cubed and the fourth root of x fourth, and this also becomes just x. So instead of taking it out, it looks like I take it out. You can say that you take it out of the radical sign, but what we are really doing is separating and simplifying. Okay, so I separated, I simplified, and now it looks like the x came out of the radical sign. And you can say, again, you can say that you took the x out of the radical sign, but that's just like an abbreviated version of what we actually do, which is separating and simplifying. Anyway, the x is outside of the radical sign. Now I have an x, the numerator, and an x on the denominator. So when you have the same thing in the numerator and the denominator, that is equal to 1. So you can say that this x cancels with this x. It doesn't really cancel, they don't disappear, they just become the number 1. And since all of this multiplied by 1 equals the same thing, all of this, so I don't have to write it. So these two disappear, but they don't actually disappear. They're still in there somewhere, but they are a 1 and I don't have to write it. So after that, I have the number 125 cubed. But 125 is also 5 cubed. 5 times 5 is 25, times 5 again is 125. So I have 5 raised to the third power, raised again to the third power. Okay, 5 cubed, cube. When you have that, what you can do is keep the same base numbers and multiply the exponents. Okay, that's the rule with the exponents. That's the rule of a power raised to another power. So we have 5 cubed, 5 to the third power, raised again to the third power. That becomes 5 with an exponent equals to 3 times 3, 9. So now I have the fourth root of 5 with an exponent 9, or 5 raised to the 9th power. What I can do with that is now separate it, because it is convenient for me to separate it this way. Okay, now it becomes 5 to the 4th power multiplied by 5 to the 4th power multiplied by 5 to the 1st or power, or with an exponent 1. In this case, when I am multiplying the same base number with different exponents, the rule is that you keep the same base number and you add the exponent. This is different. This is not one power raised to another power. This is different base numbers, I mean the same base numbers with different exponents being multiplied by each other. So if I multiply all of this, I get what I had in the beginning. 5 raised to the 9th power. 4 plus 4 is 8, plus 1 is 9. But what's convenient now is that I have exponent 4 and a root with grade 4. And the same thing here, exponent 4 again. So what I can do is take these two 5's outside of the radical sign. Okay? And by doing that, what I'm actually doing is first separating them into their own individual radical sign, into their own individual roots, and simplifying them so that each one of them, this simplifies into 5, and this one also simplifies into another 5. So again, it looks like I took them outside the radical sign, but what I did was separate and simplify. Again, this is a step that if you know it, you can skip it and just take it right outside of the radical sign if you see it with an exponent 4 and the grade is also 4. So 5 times 5, well, you know that that equals 5 squared. Okay, so I write it as 5 squared, and the denominator is 5 cubed, which I can also rewrite as 5 squared multiplied by 5 with an exponent 1. 5 squared with 5 multiplied with 5 with an exponent 1 equals 5 cubed. Keep the same base number, and I add the exponents. Okay, so now what happens? I have 5 squared on the numerator and 5 squared on the denominator. As it happened before, these two, same thing in the numerator and the denominator, equals 1. So I do not have to write this 1. I can just forget about it. It looks like they disappear, but no, they became the number 1. And it is unnecessary to write the number 1 when you're multiplying something by 1. Okay? And now also, same things happen with the exponent equal to 1. 5 with an exponent 1 is just 5. So we have just 5 in the fourth root on the numerator, and in the other 5 that is left in the denominator, I don't have to write the exponent 1 because, again, 5 with an exponent 1 just equals 5. So we cannot simplify anymore. We can get rid of this 1, and what we're left with is just this expression. Let's see what we had at the beginning. We started with x multiplied by y cubed, multiplied also by the fourth root of x, and all of that divided by the fourth root of 125x. We end up also with x and with y cubed, but now we have the fourth root of 5 on the numerator, and all of that divided by 5 in the denominator. And that is the end of the rationalizing of this expression and then the simplification.